Hey folks, welcome back for another episode of Code Club. I am Pat Schloss. I am a professor at the University of Michigan in the Department of Microbiology in the med school, and I love sharing with you my thoughts and approaches to recreating data visualizations that I find in the scientific literature. If you've never watched this live stream before, well, welcome. It's great to have you joining with us. Perhaps the best way to kind of get a foray into what I am doing here is to go to rifamonas.org. I'll go ahead and drop that link in the chat here. Would love to have you tell us who you are and where you're joining from as you log in today. If you're watching this live, if you go to that page, you can join the mailing list every week. I send out a newsletter that kind of approaches data visualizations from like a 30,000 foot view. And so last Friday, I posted this article talking about this data visualization. And again, I'll go ahead and paste this in here. And this heat map is interesting to me because it also has a dendrogram. And as I talk about in this newsletter, I think, is that there's the tree on the left, and then there's actually 4 heat maps, right? So there's 1, 2, 3, and then 4 heat maps. And this was published in a paper called Impact of Intensive Control on Malaria Population Genomics under Elimination Settings in Southeast Asia. This is an open access article, and what's even better for us is that they make the data available. And so one of the challenges I find in figures like this is that they're very common, but there's a lot of data in here, right? So a lot of data is a problem, right? And sometimes you will get the data available for the heat maps, but not the dendrogram. And so what I appreciate about this figure is that they provide the data in the heat map here, which actually is used to make the dendrogram, okay? And so we have all the data we need to recreate panels A and B. Now, I don't know how long this is going to take me. I am going to set as my goal to create panel A. If I have time, I'll go ahead and make panel B. My goal in today's episode is to recreate this figure. Now, if you watched on Monday, and if you've subscribed to the channel, which I encourage you to do, you know that, well, I found a number of problems with this visualization. And so this critique video, like I said, went up on Monday, and just a number of problems with it. And I will probably touch on some of those things along the way. And like I said, I didn't like the visual. I thought it was too busy. It didn't have context with the main article. The bottom panel is particularly a mess because the color is inverted from what I think it should be, or the years are inverted from what it should be. It took me a long time to figure out what was going on there. But again, I'm going to focus on panel A because I wanted to play with how to create a dendrogram in R. Dendrograms are very commonly used in evolution, in genomics, in ecology, and those are all fields that touch upon my field of microbiology. And so I've been afraid to build a dendrogram, and so I wanted to give it a shot and see how we might go about doing it. A few little things along the way that I am going to try to clean up on this would include things like the fact that this heat map is not square. And it is a square matrix, squared relatedness or dissimilarity matrix. And so the fact that they made it rectangular, it's wider than it is tall, gives the illusion that there are more samples in the columns than there are in the rows, which is not the case. The legends over here are also a bit of a mess where there's kind of like 2 columns, but it's just weird. And yeah, so we'll play with this along the way. I'm interested in how they made this, how they did that. So one thing I do want to point out is, well, I'll come back to that. Okay, so like I said, this type of visualization with heat maps and dendrograms, or dendrograms and other data, is pretty common in the literature. And so this morning I went through and recent issues of like Nature Genomics, Nature Microbiology, and found a few examples. And so this is coming from Systemic Design of Combination Therapy. This is in Nature Genomics. So again, you can see dendrogram on the left of these 2 panels. Oh my gosh, there's so much data for 2 subpanels. And then they have heat maps next to the dendrograms, right? Along with also some kind of like annotation of the rows. right? So that's one example. Here's another that is also from Nature Genetics, where they have a phylogenetic tree on the left, and on the right, they have accompanying data. Here's one from Nature, where they have a dendrogram across the top. They have a variety of, well, it looks like, I would call these heat maps, the first 2 rows. And then they have stacked bar charts, oh my gosh, in 3 and 4. And then this is a bubble chart. And then this is a heat map. Oh my gosh. And thank goodness they did not make the data available, because I would feel so tempted to go about recreating that. Wow, that is a lot of data and probably totally uninterpretable. Anyway, so here's another example. Again, a phylogenetic tree next to, I don't know what you would call this, kind of like a scatter plot with like these links across it. It's actually kind of cool looking. Don't know if it's interpretable. And then here's like the granddaddy of them all. This is very common, unfortunately, which is basically what I have been showing you, but in radial coordinates, right? So there's a phylogenetic tree, and there's, well, it's kind of like a rug plot, but also kind of like a heat map all the way around it. And it's just like, makes me go dizzy trying to look at it, okay? So those are some examples, again, of something like this, right? And so in some ways, this seems so much simpler than something like, where was it, this, right? But again, I think it's the same idea. And so because the data are available for this, I'm gonna make this. The data aren't available for those other examples. And so when I saw these data were available, I kind of jumped at the opportunity, okay? So let's see who has been joining in. Max from Uppsala, welcome. Doing some lab work and watching along. Awesome, thank you. John from Barrington, wonderful. Lisa from Germany. Saeed from Somalia. Mike from the UK. Mark, who I think is also in the UK. And Inlay, or Hassan from West Virginia in the US. Great. So we've got the US, Europe, Africa represented. I'm sure we'll get some other continents represented as we go along the way. As we get into this, I also just want to comment briefly to put in a commercial plug for myself that if you're interested in these types of critiques, things thinking about data visualization, and you need extra help, by all means, shoot me an email, and I would be happy to work out some type of consulting arrangement or coaching arrangement with you and or your research group to help improve your own data visualization skills. This is something I'm really passionate about. Hopefully you can tell from these videos that I put out there, and I'm really excited about the opportunity to share this with you in particular or with your research group. So by all means, get in touch with me. You can reach me at pat@rifamonas.org, or I've got other emails out there if you Google me that you can get a hold of me, and we'll figure something out. So that would really, that'd be a lot of fun to be able to work on you with your particular data visualizations and your questions. A lot of what I do in here is looking retrospectively. Someone published a figure like this, and then I say what's wrong with it, right? Or what's good about it, right? And then how would I recreate it? But it's also more rewarding, I think, to take that knowledge of what we've learned critiquing other visuals and use that then to create visuals from scratch. And so that's what I would love to be able to do with you, okay? Max is in Oceania, and we've got Mark, from Australia. So check, welcome. All right, so as I've mentioned, these data are publicly accessible, and this paper itself is open access, so you should be able to get it. And so I love seeing this link at the bottom that says source data. And so again, we're looking at figure 2. And if I right click on this or hover over this, I see at the bottom of my page an Excel workbook linked, and I can go ahead and copy the link address. And then if I come over to my RStudio, I've got this set up already with a few different packages. I'm going to paste that URL in there for just a minute. I'm going to be using the I'm going to be using the tidyverse read Excel for reading in Excel workbooks, like the thing I just copied over. Show text, it appears to me they use the Nunito font or something like that, and so we'll use that. And then we will do that using show text. And so also I am going to be using Patchwork to compose the heat maps and the dendrogram together to make a single figure. So I'm going to go ahead and load all this. I've also created a ggSave statement down here at the bottom. And so the dimensions I've given here are for panel A, the top with the heat maps and the dendrogram. I have made it wider. So the published version in a PDF didn't use the full width of the page. And so I'm going to assume that we were using the full width of the page. And so then using a height of 4.85 inches for panel A would give us the same aspect ratio as what they had. And we'll talk about maybe changing that height to make the plot square as we go along. And if I used a height of 8.33, that'd be for both panels, okay? And let's go ahead and take this, and we're gonna wrap that in quotes, and I'll call this XLSX URL, and get that loaded. And then we'll do XLSX file, and I'll call that figure1.xlsx, or actually it's figure2, not figure1. I do figure1 so many times, but yeah, figure2. And then we can do download file, and we'll do XLSX URL XLSX file. And so we download that. And I seem to have, all right, I'm gonna then go to my, I've got a dendrogram heat map directory, and I can see figure2 XLSX there. If I open that, and let's make it a little bit bigger so you can see it, you'll see that this file has 3 tabs. So the figure2A matrix, and again, if I zoom in some more here, you'll see that the row names and the column names are the genome sequences of the parasite, right? And then those are those values. These are relatedness values, whereas then these are the data for figure2A, the info, right? So these are what's across the top in those bands. And then figure2B are the data at the very bottom of the plot in panel B, right? So for now, we're gonna focus on figure2A info and figure2A matrix, okay? All right. And let's see. So let's go ahead and read in the first. So I'm not sure which one I want to do first, whether the bands across the top or the heat map. The big heat map, they're all heat maps, right? So why don't I just go ahead and read these in, right? So I will do read Excel, and we'll do XLSX file. We'll do sheet equals figure2A matrix. And I think that looked pretty well formatted, right? Aside from being wicked long, this has 1,726 rows and columns. You'll recall if you watched the critique video that they talk about actually having more genome sequences than what I have here, or that they provide here. And so we probably won't have like a perfect representation of what they had, but I think we should be pretty close. Okay, so this is, I'm going to call this relatedness. And if we read that in, then notice it takes a beat. Also, that first column, it's assigning the name of point, 1. So if I look at relatedness, right, like that's that column there. And maybe just to make that go away, we could do rename. And I always forget the order. I get rename and recode switched, but I think here I'm going to call this sample A. And then we will then replace the ... 1 with that. And then the relatedness is this. So now we've got sample A as a column name. We're in good shape. And so now what we're going to do is another for the metadata. So we'll do, or the info, right? So we'll do read Excel. And I called it XLSX file sheet equals fig, what was it? fig.2a.info. Okay, so let's look at that. And so then this is, I think, nicely formatted. And yeah, so I'm noticing that Mark put some code over in the chat. I want to see something. Something we've seen with these files recently is that they have like hidden characters. And so like when I copy over from Excel, sometimes they put like a red period in here. And that doesn't seem to be happening here. And I think that's what Mark is providing here. I'm going to hang on to that for just a minute and see if we need that. I'll go ahead and copy it, and I'll throw it up here maybe. Like that period is an example of what I'm talking about. That's kind of ironic. Let's see. It's not letting me copy it very easily. Okay. So I will call this, I think he called it conv non-break space xlsx. Get rid of that. And then maybe put this on separate lines. And yeah, I'll hold on to this for now. I don't know that I need it necessarily, but let's see. Okay, so I'm gonna go ahead and save that there. And right, so then we got this file where we have the ID and all those things. I'm gonna make all those column names lowercase. We'll do rename all to lower. And so that'll apply the to lower function to all of the column names, which we can now see. And I think I will also, yeah, let's leave that like that. And I want to look back at the original here real quick. And so they've capitalized like the N in no MDA and before and after. So I'm noticing like the no here is lowercase. I want to go ahead and do a count on MDA. And so it's after, before, and no MDA. So while I'm here, why don't we go ahead and do a mutate on MDA to do what? Let's go ahead and capitalize the first letter. I don't know if there's like an str to, let's see. Sometimes these like special helper functions, like str to sentence or str to title, do weird things with things that are all caps. It's like this, right? So like that MDA was all caps and now it's lowercase. And so this doesn't really help. So let's go ahead and do mutate, and I will do case when MDA equals after, and I'll make that then become after. And I'm sure there's a way I could write a function to only change the first character. And we've got Jordan from NCRC across campus from me. Welcome, Jordan. And then Smile with Kyle in Amsterdam. Welcome. And then before, and then MDA equals no MDA. And that then becomes no MDA. Okay. And so now let's pipe this to our count on MDA, and that all looks good. Okay. So at this point, trying to get stuff all set up. I'll call this info. Some people don't like the word metadata. Whatever. So metadata, info, whatever you want to think of it, that's cool. All right. So we've got our data loaded, at least for panel A. And let's go ahead and let's start at the top. Let's start with those three bands. And so we're going to start with info. Actually, let me think about it. I think maybe we'll start with the relatedness. Let's start with that large heat map and then create the dendrogram, because the dendrogram is going to change the order of like our rows and columns. And I want my info or metadata to be in the same order as my heat map, right? My large heat map. So let's start with the relatedness data. Okay, so we've got relatedness. And what we're going to want to do is to give this to a function called hclust. And hclust is a base R function that does hierarchical, that's the H, hierarchical clustering, right? And so that needs a distance object. So right now we have a tibble and it's a similarity, right? And so relatedness goes from 0 to 1, with 1 being highly related, 0 being not related. So we kind of want the opposite of that, right? And so I'm going to go ahead and let's see. Let's turn this into a data frame, okay? And so we'll take relatedness and we'll go ahead and do column to row names on sample A. And so this then, oh, that needs to be in quotes. This now creates a data frame, which is monstrous. If I pipe this to str, I now see that it's a data frame with all these columns, right? It's a data frame, 1726 by 1726. Great. And if I want to subtract 1 from every column, and I'm not really sure how to subtract 1 from every column in a pipe, except to make a function. So I'll do subtract 1 as a function, and it's going to take x, and it's going to be x minus 1, okay? And so now what I could do, I think, is subtract 1 on the stuff coming through the pipeline. And so now let's call this what? I'm gonna call this distances, right? And so now if I look at distances 1 to 5, 1 to 5, just gonna look at the upper right corner. I see, I did it the wrong way. I want 1 minus x. All right, so now let's try that again. Right, so now we have zeros and we have large values for things that are far apart from each other, okay? And this is a data frame, but I want it to be a distance matrix to go into hclust. So I'll do then as.distance, and maybe it's as.dist, okay. So now if I do str on distances, I see that is it's a distance object, right? That's got these distances as well as these labels, okay? And we've got, sometimes I don't know where these names begin or end. So the Jabulan from South Africa. And Mark, I see your comment about str to title with hello world. And so the problem that I see if I did like str to title on, say I want like hello world, right? But I want the H to be capitalized and I want the world to stay capitalized. What it's going to do is it's going to make the H and the W capitalized and the ORLD lowercase, right? So what I really wanted was like capital H, hello, and then all caps world. And so that's where string to title or string to sentence, right? Like that also falls down. So there's a way I know to change just the first character, but I'm spacing on it now and whatever. It wasn't so much that we had to change that got worked out pretty easily. Okay, so now we have our distances and we can feed that into hclust on distances. And this runs and we don't get any output, right? So I'm going to call this clustering. And what we could do would be like plot on clustering. And we run that. We get that. That's a pretty hideous dendrogram. And even if I write this out to a file and then open up the file, let's see. For some reason, it's not coming out. All right. I'm not seeing it there. So not totally sure what's going on with that, but yeah, we'll figure something out here eventually. Okay. Oh, because ggsave probably doesn't work on plot. If I wanted to see this, what I could do would be like png figure2.png. I think ggsave only works with ggplot stuff, right? And then I do dev off. There we go. There is our dendrogram. And as you can see, it's a hot mess, right? And so, yeah. So we have some work to do, right? So there is a function called, or a package that I'll add here, library ggdendro. And ggdendro makes it easy to extract information from hclust objects, right? So if I do like str on clustering, what I get are a lot of information, right? Like the labels, the method, the call, these types of things. This is information about like the height of the different branches here on the right, yeah, where things get merged. And that is ultimately useful, but really hard to work with. And what I want to be able to do is to work with this dendrogram in ggplot2. And so when I look at this, right, and look at the dendrogram, you can think, well, there's no doubt like a special fancy geom dendrogram function, right, or something like that. And I'm sure there is, and I'm sure ggdendro has something like that. I actually know it does. But really, what's in here, what this is something you could make with geom segment rather easily using the output from ggdendro. And so I have to remind myself ggdendro. If I do like ggdendro and then 2 colons, I get the various functions, right? And so what I want is segment, right? And so this will then give me the segments on clustering. And I can then call this branch data. And then I could look at branch data, and that is empty. And maybe, let me look at this. Segment extracts line segments, label extract labels, blah, 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 from a dendro object. And so I think what I need to do here first is make this as.dendro on that. Yep. Be as.dendrogram. So that's still nothing. All right. Oh, dendro data. Okay, I think that's what I need to do first, is dendro data. And then with dendro data, I can then do this other stuff. All right. Yeah, so I'm seeing what I want to do down here with dd data, dendro data, and yeah, so maybe what I need to do then is dendro data on clustering. And so then let's throw that in here. And then there's the branch data that gives us, oh, if I come back up to the top here, somewhere here, is x, y, x end, y end, right? And so those are gonna be like the starting and ending coordinates for all the different branches. And maybe what I'll do is I'll pull this out and do ddata as dendro data, and then I can throw that in here. And then I'm also going to want, I think the other argument that it talked about in here was maybe leaf label. So I can do leaf label on ddata. So that's empty. Why don't we try label? And so label then gives us all of the different labels, and it's in order. And so I'm curious what the column name is. Label. Okay. So $label then would be branch, or the tree labels. Right. And so now if I look at that, I get basically the ordering of the different genomes in the tree, okay? And so that's then a vector. All right, so again, just to kind of take a step back, I read in the relatedness matrix, but the relatedness matrix is really a measure of similarity. And to get the clustering done, I needed to convert that into a distance matrix, okay? And so to do that, I needed to take the square tibble, and then I needed to turn that into a data frame by taking that first column, sample A, and moving that to the row names. And so this step here on line 35 makes that conversion for me to a data frame. I then needed to subtract 1 from all of the values. Suppose I could have also done something like this with a mutate all or something like that, but whatever, this worked. And then I converted it to a distance matrix. And then hclust takes that in, and by default, if we look at hclust, the default method is complete, okay? So we'll probably want to hold on to that and remember that, okay? And so then we extract the dendrogram data from clustering, and then we parse that to get the branch data and the tree labels. If I look at ddata itself, this is a list that has basically all the same information, right? Like, so these helper functions, like segment and label, really aren't necessary. I could have done like ddata $segments and gotten the same thing as what this segment function is doing for me, right? So anyway, but normally I'm not really excited to learn all sorts of new packages, but considering there's no dendrogram support in ggplot2, I thought this was worth doing. Now, in the original, they used a package, in the original paper, they used a package called heatmap, P-H-E-A-T map, and we'll come back to that here in a minute. All right, so again, we have this branch data, which is a tibble. And so I'm gonna take branch data, and we'll pipe that to ggplot AES. X is going to be X, Y is going to be Y, X end is going to be X end, and Y end is going to be Y end. Right? And so I'm creating the dendrogram, right? And so then we want to do geom underscore segment. And then we'll go ahead and run that and generate the figure. And I think I lost my figure somewhere. I'll reopen that. There we go. And so again, this is looking at like the top half, top 2/3 of the figure. So there's our dendrogram, right? And we've made it with ggplot2. Now it is what? It's horizontal, and we want it vertical, right? So let's go ahead and change that. And so I think what I will do is switch my X and my Y. And so we can do X equals Y, Y equals X, and then X end equals Y end equals X end. All right, so that then made it kind of point in the opposite direction of where I want it, right? So like the root is somewhere over here, and the tips of the leaves are over here. So again, this is like really hard to look at because there's like 1,600 samples here, right? And that's just way too much. So what we could do would be like scale X continuous, and I could then do transform equals reverse. Okay. And so now what we see is that we have the tips of the branches over here, and then the root is, say, over here. Okay? Cool, right? And I think what we want to do, though, is like on the scale Y continuous, let's do, we'll do breaks equals 1 to, it's going to be length of tree labels. Or maybe I could do seek along. Does that work? I have to spell it right. Yeah. So I could do seek along on tree labels, and then I can do label equals tree labels. And so there we go. Of course, those are horrible labels, but we'll work. We'll deal with this eventually. Okay. So we have our labels here on the left side. Ultimately, we're going to get rid of them because, again, like the original, it doesn't have those sample labels on it, right? So I just want them there for purposes, for a reason, and we'll come back to that. Okay. So again, we have the samples as those tree labels, right? And something I should do is to double check that like info and relatedness have the same samples, right? And so if we do info, maybe I forgot to load this. Okay, there we go, info. So info $ID is that first column of samples. And then we also had relatedness $sample A, and those are those names, right? And so what I'd like to do is see if all of the info is in the relatedness, okay? And so there's a few different functions that you can use to do that. And so let's first just start by doing like length on info ID, length on relatedness sample A. We get 1726 for the relatedness and 1617. So we know there's actually difference, right? And if I do like ncall on relatedness, I see there's 1727. So there's an extra column, I'm going to assume, because we've got that sample A column name, right? All right. And yeah, so let's see how to do this. So I'm going to say, if I take info $ID, are those all in relatedness $sample A? And actually I want %in%. So that's going to say, are all of these in this, right? And maybe what I'll do is like sum on the ones that aren't, right? So how many are in info that are not in relatedness? None, right? So everything that's in the metadata is also in the relatedness of sample A. Cool, all right. And so then I think what I'll also do would be like call names on relatedness. And of course we have an extra column name in relatedness for that's sample A. But here, hopefully this will also be 0. It's 0. Cool. Yeah, let's do the same idea here. So we'll also take the call names and say how many of those are in relatedness sample A or are not. And this should be 1, right? So that should be like the sample A column. Fix this. 1, right? Okay, so cool. So basically, everything that's in info ID is also in relatedness, but not everything in relatedness is in info ID. Okay, so what that tells me is that I need to go back and do a little bit of work, right? I need to get the stuff that's in info and then use that to effectively prune, if you will, my relatedness. So I think what I'm going to do is I'm going to go ahead and put the info first. And here then I could do like a filter, and I can then do sample A %in% info $ID. Okay. And so again, this is going to hopefully give me 1617 row data frame. And sure enough, we get a 1617 row data frame. Cool. So that gets us the rows. I could like pivot longer and do the same thing like on sample B on another column, But let's do it with select. So we'll do select, and then we'll do sample A, and then I'll do all info $ID. So what this means is I'm going to select sample A, and then all of the names that are in info ID. And, oh, can't have missing values. Coursing logical. Okay, let's see. Let's double check. This worked. Okay. And then my info ID is like that. And let's see, try it without the sample. All right. You know what? I think I'm going to go ahead and do the pivot longer after all. All right. That's okay. So we'll do pivot longer minus sample A. Names 2 is going to be sample B. Values 2 will be relatedness. And so that gets us this data frame, right? And then I'm going to do a filter. This filter, and then I'll do basically the same thing with B. Okay. And so this gets us that many things. So if I take this and let's do SQRT, should get 16, 17, or oh. What am I doing wrong here? Let's see, this is, I think, a different number than what I had. Okay, I must have copied and pasted the wrong number. Okay. So that's then the 16, 17, right? And so now what I can do would be like pivot wider, names from, I'm going to say sample B, values from relatedness, right? And so then this gets my relatedness, and we have a 16, 17 by 16, 18 matrix. We're good to go. And so now if I run these, then we get the expected values, right? Cool. So I'll go ahead and comment that out. And so now we've got relatedness. And so let's go ahead and regenerate our distances, our clustering, and all this stuff. And so now we've got, yeah, okay, good. So we have our dendrogram, as rough as it looks. Just hang on, bear with me. I'm going to go ahead and call this tree and save it as an object. And so now what I want to do is make the heat map, right? The large heat map of relatedness values. And so here again, we've got relatedness, and I'm going to have to go ahead and do the pivot longer again. Maybe what I'll do will be like this. I'm going to grab that from relatedness and throw that in here to my pivot wider, okay? And that way, I don't have to keep doing like the pivot wider, pivot longer, blah, 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 right? So this then, relatedness is a tidy data frame. And then the first step to calculating the distances is to make it wider into a data frame, okay? All right, let's make sure everything works. And we're still good. All right, so like I said, we have relatedness. And we'll do ggplot AES. On the X, we'll do sample A. The Y, we'll do sample B. And fill will be relatedness. So again, the tree is on distances, so that's like 1 minus the relatedness, whereas the heat map is the relatedness from 0 to 1, okay? And let's see, that Then we can do geom_tile. Oh, this is going to be slow. Right. So there is our heat map. Oh my. We have some work to do, right? I can see that there's a diagonal along the diagonal. Also, my samples are not in the same order as my tree, right? Like there's very little obvious clustering. So let's go ahead and worry about that first. And I'm going to also go ahead and call this our heat map. That way, because when I run it as I just did, like basically what I have highlighted here, I'm recreating the plot twice. And it's slow, right? Like that's 1617 by 1617 matrix. That's going to take a minute. So in here, let's go ahead and do sample, or we'll do mutate sample A, and we're going to make it a factor, right? Sample A, and the order that I'm going to use are tree labels. And then we'll do the same thing with sample B. Okay, so we'll get that, pipe that, and save it. And there we go. Now we can see that we have clusterings, albeit a bit different. You can kind of see the makings of what they have, right? But like the first concern is the x-axis, I think, needs to be flipped, right? If I look at tree, oops, and then ggsave. Well, I'm going to want to put these next to each other, right? So let's think. Well, let's go ahead and flip the order of the x-axis, right? And so again, I can do, well, what do I want to do? So sample A, I can reverse the tree labels. So we'll do that up here in the factor. So because sample A is on the x-axis. There we go. So now we have the diagonal in the same direction as theirs, right? Now the question is like, did I get the ordering of the factors straight? So let's go ahead and bring this together with the dendrogram. And so to do that, we can use patchwork, right? So we'll do a tree plus our heat map. Oh, I'm going to call this combined. And then we'll also do combined here. Because it's taking a second for it to combine things together. Okay, so I want to be able to use the same axis on the y-axis in both plots. And it will only let me do that if they're in the same order. Now, I think they're in the same order because I see a big cluster here matching this big cluster matching this matching this. Okay, so I think we're good. But to do that, we need to go ahead and do plot layout, and then we'll do axes equals collect. Okay, so we're going to collect the axes that we can. And now what we see is that we no longer have those axis names here, but it's doing weird things, right? It's got this expansion on the tree. So let's go ahead and turn off the expansion on the y-axis of the tree. And we can do that with Well, we can do that with scale y continuous, right? I can do expand equals c 0, 0. And I'll also go ahead and do labs x equals null, y equals null. And I'm going to do the same thing. Actually, you know what? I'm going to pull this expand out, and I'm going to do it in a chord Cartesian. And I'll do expand equals false. Okay. And I'm going to do the same thing after I load that for my heat map. And then let's combine them together and see what it looks like. And there we go. Okay, so I think those line up much better. And I can now see that my clusters in the tree match the clusters in the heat map. Okay. Now, you might be looking at theirs and think, that looks a lot different than theirs. I mean, yes, the color, the ordering of the clusters looks different, but the tree looks very different, right? Like the branch lengths on theirs is larger at the top and smaller at the bottom. Whereas pretty much like all of my branches are long. And I have a suspicion that they did not do what they think they did, okay? And so just as like an aside, based on some investigation I did, if I do library feet map, I can do feet map on, let's see, that would be relatedness. Or actually, no, I wanted to do it on distances, right? Okay. And if we run this, when I'm recording videos and editing, this is the part I cut out because it takes like so long. So, all right. So let me see who's been tuning in. I have Dr. Abdul Rahman from Kabul. Welcome. And we have Robert from Oakland. Cool. And so if I hide myself and I bring up this other plot, we get effectively what they had, right? Like they have like the output gave us this top dendrogram, which is the same as what's on the left. So we don't really need that. And the colors, of course, are different. And the ordering is different. And the tree looks like theirs, right? And so if I look at the help for feet map, what do I see, right? So I'm looking for like clustering methods. So it says method equals complete, right? And let's see, I think there is also a distance, right? So right above it, clustering distance rows, clustering distance calls equals Euclidean. And if you come down to the help for clustering distance rows and calls, it's the distance measure used in clustering the rows. Possible values are a correlation and all the distance applied by dist, such as Euclidean. And so the default was Euclidean, right? So if the value is none of the above, it is assumed that the distance matrix is provided, okay? So I'm going to, let's see. I believe there is a tree height call. So I'm going to turn off the tree height call. So I'll say 0. And let's then do, what was the function? Clustering distance rows. And the default is Euclidean, right? And if we run this, it'll save this as test.png. Or, oh yeah. So let me try this again. I'm not quite sure what's happening. Sometimes with big data sets like this, it takes a long time for the plot to even show up in the plotting tab. And so let's try it my other way. All right, PNG, and we can do dev.off. So it lost the heat map at the top. And yeah, okay. I don't know what I'm... Oh, bother. All right, well, this doesn't make for a great video, but I'm not sure what's going on here. I think ultimately it's unhappy because it's so big. And what we were seeing in the plot was the basically the output that we had before, as we expected, but we lost the columns at the top, right? And so doing some digging through the heatmap software and the code, what I noticed was that it is taking the distance matrix that I gave it in distances, and it's calculating the Euclidean distance between all the rows and all the columns, right? So it's taking a distance matrix and it's calculating distances on the distance matrix. When what we'd really like to do would be clustering distance equals distances. And let's see what that looks like, if we can get it to output. Ah, and we've got someone from Turkey joining in. Yeah, so as soon as you work with trees, R is getting pretty slow. Yeah. And I think it's not just trees. I think it's the monstrous heat map, right? And yeah, this is pretty unhappy. What happens if I export? And it's not letting me export. All right, let's try that one more time. So we'll do dev, or do PNG, test, heatmap, .png, dev.off. Okay, well, that's the other heat map we saw. Oh, that's... All right, I don't know what I'm doing wrong, but anyway, you get the idea here. Like, this was giving it my distance matrix, right? Here in clustering distance rows as distances, right? And so I think what the original authors did was they ran like this, right? And so basically, again, what heatmap does is it takes the rows and the columns, and unless you give it an indication that you have given it a distance matrix, it calculates a distance matrix based on your distance matrix, which is not at all what you want to do, right? And so, again, this is, again, me getting one result, them getting another result, and trying to figure out why we got different results. Hopefully that makes sense. This has been a little bit cumbersome dealing with the plotting window, but hopefully that makes sense. All right, so let's come back and see what we've got. And open that up. And so again, we've got our heat map, we've got our dendrogram, the axes match each other. And again, it's going to look different than theirs because I think they made assumptions about how the tool was working, and those assumptions weren't true, right? So they're doing complete linkage. We're doing complete linkage. They're doing a distance matrix based on a distance, calculating distances between distances, which again, hopefully doesn't make sense to you. So, all right, now let's go ahead and Well, let's see. Let's go ahead and clean some of this up. All right. Let's go ahead and add our bars to the top. We'll come back eventually and we'll clean this all up to make it look better, I promise. But let's go ahead and come in here. And for now, I don't want to mess with the tree or the heat map because as we saw, that took a while to load. And so what I will do will be to take the info data frame like this, and we need to create 3 heat maps, right? We need the MDA, the year, and the Kelch 13. So let's start with info, and we actually want to change the order of info, right? Because we want it to match the order that we had in the large heat map. And so that was sample A, right? So I'm going to go ahead and grab that line and plop that down here. Only it's not sample A, it's ID. So we'll make that ID. All right. And so now, I mean, we can't really see it, but ID, well, we can see it's a factor, but we can't see that anything's changed, right? And so now we can do like ggplot AES. On the x-axis, let's put the ID. On the y, I think it was MDA, right? That's the top one. So we'll do MDA. Sorry, y will be 1. Fill will be MDA, right? So we're gonna have a single ribbon of MDA values, and we'll then do geom tile. And if I must have screwed up my plotting tab. All right, let's go ahead and I'm going to take out the combined for right now. And so now what we get is MDA with the after, before, and the no MDA. And again, we have these stripes, we have the ID. Let's go ahead and, like we did before with these other plots, I'm going to add this chord Cartesian and the labs equals null to both of those. And actually, that's not totally true. For y, I'm going to want that to be MDA, right? So we've got MDA there. And so what I'm looking at in the original was that we have these bands, these ribbons, and the title or the descriptor is on the right side, right? And so what I envision is if I take this, I should be able to put it on the right side instead of the left side. And then I can pivot it 90 degrees, okay? So to do that here, what I could do would be scale y continuous, and we can do then sec.axis equals dupe axis. And then here we're gonna like turn off a bunch of stuff, right? So like we'll do breaks equals null, labels equals null. And so now what we see is that we've got MDA on the right and also on the left, but ultimately we'll turn that off. And so what I'd like to do then would be plus theme, and we'll do axis.title.y.left, and we'll do element text, and we'll do angle equals 0, I think. Oh, I did left. I meant right. Silly me. Okay, so what we get is that that has been right justified, or sorry, it's been turned 90 degrees, but it's justified at the top. And so we've got like a weird plot here because we only have like one row. So what I think we also want to put in here then would be like vjust equals 0.5. And that then puts it down in the middle, okay? So that's good. Eventually we'll be getting rid of, I think, all the stuff on the left and the bottom, but I want to wait until we pull it all together to do that. And so this then is MDA, okay? And I'm going to copy this, and I suppose I could probably make a function to do this, but why? I'll do year, and then year will be the title, and the fill I believe it had a special column name for the year. So year clean, I'm going to use year clean. I don't know why that's different than just straight up year. So I'll put year clean in there. And then again, this is year. And so now we have our year data. And yeah, let's stick with that. And then we also have the Kelch 13. So I'll call it Kelch. Is it Kelch? Yep, Kelch, okay. And then the title is Kelch, and it's all one word, 13, but it's italicized. So I'm going to use element markdown from ggtext, and I don't have ggtext, so we'll do library ggtext, get that loaded. And I'm actually going to, for consistency, use element markdown for all three of these. And I think that should be good. And now I'm going to create a new combined, which I'll do combined is MDA plus year plus Kelch plus plot and plot layout. And then we'll do axes equals collect. And so what we should get is a single x-axis from this. And we did not, because we have three side by side. And but we see our Kelch 13 is italicized. That's great. Okay, so what I need to do here then, believe would be I could do like n call equals 1. There we go. Now we've got our three bands on top of each other. And I think I forgot to change the ggplot. So this should be Kelch 13.clean. There we go. All right. So, wonderful, right? So those are our three bands that are going to go at the top of the plot. Now, let's go ahead and try to combine this with the rest of the plot. What I'm trying to do here is hold off on modifying too much of the theme until the very end. I feel like that is how they want you to work with patchwork, is that there's kind of like universal theme elements that you change, and then there's kind of particular theme elements that you change. And so I'm trying to like keep those apart. I don't know how well that's going to go ultimately. One thing as I look at this that I do notice is that my year is being treated as a continuous variable because it is, whereas in theirs, it's being treated as a categorical variable. So why don't we go ahead and before we bring it in, let's go ahead and clean up these scales. And so let's look at the year one first. And so to make that a categorical, I could do like as.character on year. And so now what you can see is I've got the year there, right? And it's doing all sorts of, oh, I know what it's doing. Okay. It's doing all sorts of weird things with the legends, right? Like the orientation or the positioning is a little bit wonky. And I can fix that down here. I can, within plot layout, I can do guides equals collect. And this should make like a separate column for the guides. Like so, right? Now, of course, my guides go off the screen. We'll clean that up here. So let's go ahead and look at, we'll add a geom or a scale fill manual. We'll do name equals MDA. And then we're going to have breaks equaling something and values equaling something, right? And so we're going to have after, before, and no MDA. All right. And then quote, and then I need the colors. And to do this, we'll bring in the digital color meter, my favorite handy dandy little tool. And there we are. Wrong page. Come on. Okay, there we go. So it's this like baby blue color. Copy that into after. And then the before is this kind of burnt orange color. And then the no MDA is a grayish color. All right. There we go. And so now we can see we have the after, before, and the no MDA, and we've got the colors that more or less matches what they have. Now we want to do the year, and let's see. Yeah, so it's going to be the same idea. So I'm going to copy this down here and put it after the scale Y continuous. And again, this is year. And we've got 2016 to 20. So do 2016, 2017, 2018, 2019, 2020. And there's probably a smarter way to do this with like a ramp of the colors, but actually, is there? Let's do color ramp. Whatever. I'll do this. So bear with me a minute as I copy and paste these in. Just takes a second or two. All right, two more. And bam. And the last one, at least for the year, is purplish color. Okay. Load that all in. And so now we see we have those colors for the year, and they match pretty well the colors that they have. Okay, cool. Now what we can do is the Couch 13 clean. And here again, with Couch 13, we're going to want the title to be italicized, right? And so, let's see, I put that in the wrong place. There we go. And it's going to be italics, Couch 13, italics. And then down here, we're going to do legend.title element markdown. Okay, and so that will get the Couch 13 to be italicized. And then we need to put in the different genotypes that they had in the original. And I think with the PNG, I can copy and paste, although the text recognition does weird things. Like it doesn't know how to interpret an I. I think that M562 is an I as well. And I think P441LH, okay, good. And you know what? I'm going to do this as a named vector. And so let me just get that set up like so. There's two ways, at least two ways that you can do set the values for their fill colors. One is with like breaks and values like I have up here. The other is to make it a named vector. And so again, if I come in here real quick and get this red in here, and then this green, like that, and as I was looking at these colors, it also occurred to me that like the color choice for these genotypes is pretty bad. They've got like a mix of red and green. They've got shades of color that are really similar to each other. Kind of like this orange color, and then the one down below it are pretty similar, and the greens are pretty similar. Again, I think that just highlights the problem with having too many categorical variables, is that there's not enough colors, or there's not enough discrimination between the colors to really see a difference. And of course, they have so many bands, or tiles, if you will, in that heat map up at the top, that you can't distinguish it anyway, right? So let me clean this up real quick. And as I'm cleaning this up, just a reminder that if you are interested in workshops or coaching on data visualization, or just help to get over the edge or over the hump of creating data visualizations for your papers or for your talks, feel free to reach out to me and we can talk more. Okay, so now we've got our legends, right, all set up with the colors matching their colors and their names. We've got 8, they've got 8 genotypes. That tells me I didn't screw something up. Maybe, yeah, okay. So now we have those 3 bands at the top, right? Very nice. What we could do is I could now combine in what we had up above, which was this, right? So I have this other combined plot. And so I'm going to bring that down. And now what we want to do is we want to pull this all together, right? And so we have 5 plots, right? And so just to kind of, again, we have the heat map, or sorry, we have the dendrogram, we have the large heat map, and then we have like the MDA, the year, and the Kelch 13, okay? And so if I do it like this, let's see what happens. We're going to get something pretty hideous. It's going to take a little bit to run. Basically, we're going to get one column with all 5 of our plots, right? So we've got the tree, the large heat map, and then the 3 bands, which is not what we want. And there's different things you can do to structure the layout. Something I think I did in the last episode was to have like a layout string, right? Where we can create a string, and then in my plot layout, instead of saying like end call equals 1, I can do layout, or I can do, sorry, design equals layout, okay? And so what we then do is we put a letter corresponding to the plot, right? And so I'm going to put a pound sign as like a blank spot. And so to the right of that is going to be, well, why don't I put these in the order that I want them? So I'm going to put the 3 strips. So we'll do like pound A, pound B, pound C, and then we'll do D and E. Okay, and so MDA is A, year is B, Kelch is C, tree is D, and heat map is E. Okay, and so now we run this, and we should get something that looks like the layout we want. We should also get one common x-axis below the large heat map, okay? And sure enough, we got it, right? So we have the one x-axis text for the right column, and we have the one y-axis on the left for the bottom row, okay? So this is it. This is coming together much better than I thought it would, right? Calls for all is a R package for selecting color palettes. Cool. Yeah, so I think they might be using Color Brewer. I think that's like a very commonly used, widely used tool. Okay, so let's start to make this look better. And I think the first thing we can do to make it look better is to remove the text from the left and the, well, actually, yeah, from the left and the right side. We need to fix the color of the large heat map, but I can't see the heat map. And so we're gonna have to play with the we're gonna have to play with the legends here a little bit. So let's go ahead and get rid of those. And so what we can do is use an and sign with theme. And so what this is going to do, as I understand it, is it's going to apply the same theme components to all of the plots, right? So I can do like axis.text.x equals element blank, right? And so this should then get rid of the x text, those long names that we can't see anyway. That should remove those from the plot, right? And so we got rid of that from the bottom of the plot. Of course, we have these tick marks, which we can get rid of as well. We don't need ticks anyway, so we'll do axis ticks dot period, all of them, element blank. And so that should remove those as well. Okay, and so I got rid of our tick marks. And so let's also then get rid of our y-axis text. So then we can come back up here. We can do axis.text.y equals element blank. And you know what? I already have that up here with axis text x. So let's remove the .x and see what this gets us. Right? And so that removed that. Now I would like to get rid of the left title, right? So if I do like axis.title equals element blank, I think it's going to remove it from the right side as well, which I don't want it to do, but let's see what it does. Yeah, oh, it actually left it on the right side. Cool. Okay, good. I'm noticing that these titles are, I think, center justified when I'd like them to be left justified. So I'm going to come back up here, and something I'm noticing again is like I've got the same theme in all three of my functions. So I'm going to cut it from one and remove it from the others. Remove that for now. And then let's plop that in here. Right, so we have axis title y right. And so let's make the h just 0. Okay, and so I need a comma there, and then I need to go back up here and reload those 3 ribbons and see where that gets us. Cool. So that did that, right? We now have, and I'm just kind of looking at the bands to make sure they make sense, right? So like we have this big cluster in the dendrogram where my crosshairs are, corresponding to this rectangle in the large heat map, corresponding to this yellow, which I think is probably the R561H band within the Couch 13. And if I look over here, I'm pretty sure that is this cluster up here, right? Because in the Couch 13, it's all solid. As I'm looking at this, one thing I remembered from the critique was that I noticed in the original that there's vertical white stripes that you can kind of see across the plot. It's hard to see because so much of the background is pretty faint. And I actually found, let's see if I can pull that back up. I actually found in the heatmap issue tracker that people are seeing break lines, white lines presenting in the columns and rows of the main heatmap plot with no data, NA data in the matrix, right? So they're kind of seeing same type of striping in their data, and people don't know what's causing it, right? So I don't think that's on the authors. I think that's on the package and perhaps like the resolution of the plot and the type of data being stored in the plot, okay? So, all right. So I just wanted to clarify that because I did raise that as a conjecture of like, what's going on here? Did they remove something from the big heat map that wasn't removed in the strips, or was there something in the strips that wasn't in the heat map and blah, 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 but I don't think that's relevant. Okay, so let's look at our layout because so currently all 4 rows are the same height and the 2 columns are the same width. And so I want to change the widths and the heights. So we can do that in plot layout where we will do widths. And we can give it a vector of 2 units. So one for the left, one for the right. So if I do like 0.1 and 0.9, then the left should take up, I think, 10%, and the right should take up 90% of the window, like so, right? And let's kind of start playing with kind of the proportion there. And again, it's hard to see. Something else that I notice is like the spacing around the individual plots is going to be determined by the plot.margin argument. So if I do plot margin, and I do, let's do 1 all the way around, then each panel will get a 1 unit margin all the way around, and that should then shrink the amount of spacing, as we see now, between each of the panels. And I think the right and the left should probably be 0 because there's no obvious gap between the dendrogram and the heat map. And so again, this is top, right, bottom, left. So let's make that 0 for left and right 0. There we go, that blends that together. But then you'll notice there's no margin around the overall plot. And so if we want to get that, then what we can do, I think it's in plot annotation, where we can then do theme. Let me put this on a separate line. Will be plot.margin, and I can then do margin. Let's do 2 all the way around. And so this will give a margin around the overall set of patchworks, not the individual patches. All right, so that didn't do what I wanted because, oh, I think I meant to do theme equals that, right? Not, I think I gave it a title of that. That wasn't what I wanted. All right. So let's see how this looks. So now we get like that 2 unit margin, I think more or less all the way around. Let's now come back to what we were doing with the plot layout. We had widths of 0.1 and 0.9. Maybe we'll go up to like 0.15 and 0.85. And then let's do heights. And let's do 0.1, 0.1, 0.1, and 0.7 for the 4 rows. Let's see how this looks. Cool. And so I think those can still be a bit more narrow, probably about half, right? So I make this like 0.05, 05, 05, and 85. Try this again. Again, I think it is like the big heat map that is sucking up all the air, so to speak. And so if I compare those, mine again, I think is still too thick. So let's go to like 0.03. And so that would then make this 0.91. And if that's not right, I'll probably just be content to stop there. Yeah, I think that's good. We again have the MDA, the year, and the Kelch 13. And I feel like those fonts are probably too big. Let's go ahead and shrink them. And I also need to bring in my text. So we'll do text equals element text, my font family rather. We'll do family equals Nunito. And the axis title Y right, let's come in here and do like size equals 7. And there we go. Okay, that's maybe too small. let's make that, let's say 8. And the other thing I'm noticing is that the font weight is pretty light. So I'm going to do regular weight. The default is 400. Let's take it to 500. And then rerun this. And that should increase the size of the font and make the font a little bit heavier, right? So kind of like that. Yeah, I could probably go even larger. What do I have? 8. Let's make it 9. There we go. I think that's probably pretty close to what I had initially. This is blacked out because I went to the file too quickly. I'm just gonna make this 8.5 and I'll call that good. Okay. Let's go ahead and shrink down the font. And yeah, so Max says that sometimes put it in CM without units, of course, as I want it to show up on the paper in the end. And that is fine. I am thinking in terms of points, right? And so like, I kind of know what like an 8-point font looks like or 10-point font. I know I don't want to go below 6 because smaller than that, you really need like a magnifying glass, which is not what I want to do. Okay. So let's think about these legends on the right. Again, like our legend titles are probably too big. They probably are, I would say 8-point. And our boxes are too big. So we'll do legend.title equals element text. And let's do size equals 8. And then legend.text element text. And I think the font there is also 8. So we'll do size equals 8. And then we'll do legend.key size. Let's make that unit 7 pt. Oh, and it's upset with me because why? Can't merge legend title theme element. Because you know why? Because I use legend title up here. So I'm going to remove that. And it reminds me that I need element markdown. So I'm going to rerun that. And then this legend title should be element markdown. Okay. Doobie-doo. There we go. And so now we've got year, Couch 13, relatedness. MDA must still be at the top. Didn't shrink my key size. Oh, because I commented that off. Okay, let's try this now. I think what Patrick does is if you've defined a theme element previously, it tries to merge what you're doing, what you're modifying in that ampersand statement down here at the bottom with what you had up above. And I think what it was telling me was, I can't do that. So now we have MDA year and Couch 13. And so that mostly looks good. I think there's too much space under the title. So legend title, let's do like margin equals margin, B equals 1. I don't know what it is by default, so we'll start with 1 and go from there. And I think that's pretty good. It could maybe be like 1.5. Let's do 2. Knowing that it's going to take a little bit of a lag to generate the image makes me like really second guess like how much time or how much I do some tweaking here. I think our legend text is really compressed. And so maybe in here we could do like margin equals margin, B equals 1. Not sure what this is going to get us. I hope it gives us a little bit of separation. And it did, but it removed the left margin. Okay, let's do L equals 2. something I'm thinking about is like the spacing of these different keys. So let's see, legend, one too many parentheses, legend, key spacing Y. Let's try that. I'll do like unit 2pt. Oh, I forgot a comma. Knew it. All right. So I think that looks better. That's more along the lines of what they had with kind of that spacing. Yeah, I like that. All right. So we need to fix the color of our relatedness, right? And we need to change the name. So we need to work on this legend. So let's come back up to where we defined the R heat map. And here we'll do scale fill gradient and name equals relatedness. And we'll then do our limits go from 0 to 1. Although it looks like on theirs, it's a little bit below 0 and a little bit above 1, right? Like I can kind of see the white ticks there and the white ticks there. So let's do negative 0.05 to 1.05. And let's see what this looks like first. So now when I look at mine, I also see a bit of the gap at the top and the bottom, okay? And somebody had mentioned brewer. So if I do colorbrewer2.org, let me throw that in the chat as well. All right, and I want a sequential, and if I like jack this up to like 9, going from that, right? So it's like yellow or red. And I think what I can do then back up here in the heat map is there a palette? Let's see. Well, I had the low, the high, the mid, and the midpoint. Right? So if my midpoint is 0.5, my low is going to be this, and that's got to be in quotes. Right? And then my high is going to be this. And then my mid, get your fingers on the right keys, Pat. And then the mid is going to be 1, 2, 3, 4. Yep, this one here. Okay. And I screwed that up. I think it's a scale fill gradient 2 is what I'm trying to do here. There we go. Yeah, and so I used, as I said, scale fill gradient 2. And what this allows you to do is basically have 3 colors with like 2 gradients, from like a low to a middle and a middle to a high. And we get something like that, which isn't exactly what they had in theirs. But I don't know. I think that's okay. I think that looks like a reasonable set of colors. I feel like, yeah, I don't know what's totally going on with the colors there. Something else I noticed is that with mine, I've got breaks every 0.25, whereas theirs is every 0.5. So if I do like breaks equals C0, 0.5, and 1, and reload that, there we go. We get that. Now, I would kind of like this legend for the relatedness to be a bit longer and wider. And I think I can do that here in theme. Or I can do like legend.key.width unit. If I do like 8 pt, wonder what that will get me. I also wonder if if the ampersand at the end of the patchwork is going to write over what I had, right? Because down here, I have like this legend key size. And so I'm wondering if that will kind of trump what I'm trying to do. So I think that actually made it wider. I realized that down below I had 0.7. So let's make this like 11. Doobie-doo. Yeah, so that made that wider, right? So you can see that hopefully that this gradient legend is wider than these up here. Let's make it higher, taller, right? And so we'll do legend.key.height unit. I really don't know what it should be. I think it's currently 7. Let's make it 10 points. And yeah, that's taller, right? Yeah, I think that's good. Maybe I'll get greedy and go to 12. And then I'll probably call that good. As we're thinking one thing, yeah, so I think that's good. So one other thing that I would like to do is perhaps so on theirs, they're not making very economical use of the space on the right, I feel, right? So they have this like relatedness right up against the large heat map, and then this other stuff is to the right. I'd like for that to be a single column like we have here, but I would like this to be tucked underneath, right? So that we can get a wider plotting window. So the first thing I'd want to do is to shrink the space between the legend. And so I think I can do that in here with like legend dot spacing. Yeah, legend spacing dot y equals unit. And let's do 3 points. I'm sure that's not enough. But again, this is in the big ampersand theme function at the end of running patchwork. And so that pulled that down. We could probably do more. So if we do, I think there's also a margin around our legends. And so if I make that 0 for the spacing, that pulls that down. And I kind of like that spacing, and I like that font size, but I want it further down. So I think what I can do is I could do legend dot justification right. So this should allow me to specify the level of justification. So if I did 0, this should put it on the bottom. Let's see what it does. All right. It did nothing. All right. I think I could do legend justification, anchor point for positioning legend plot, center, or 2-element numeric vector, or the justification. Okay, let's try this. Let's try 0, 0. So I think this should put it in the bottom left justification on the right side. Okay, well, yeah, so I put that at the bottom. I can see that. And if I did, so I think this is horizontal and this is right. So if I make that 1, it should go to the top now. Yep, that goes to the top. So I don't want it, I think the default was 0.5. So let's make like 0.3, because I want it a little bit lower than midpoint. There we go. Cool, right? And now what I can do, I think, is pull it over to the left. And so we have legend.box. Well, let me do legend box background. I want to test something. We'll do element rect color equals red. So this should get me a border around my legends, because I want to see like how much margin is there, right? And so, yeah, that's the red margin. And if I do legend margin equals margin, and again, by default, it's all zeros, but I'll put those in just to make it clear what we're setting the values to. Now I should get like that red rectangle should be right around it, right? Which I do. And I also removed that spacing, right? So now if I do 3 as my vertical spacing, that should probably be a better way to do it. Okay, that's not enough. Let's make it like 20. Okay, that's too far. So let's make it say 15. And I think that's going to do it. And now what we're going to want to do is we're going to pull it to the left. And I think I can do that with legend box spacing, right? So yeah, I think that's good. Maybe I'll take that to 12. And then we'll do legend.box.spacing. And then we can do unit, and I'll start with unit 0. And I can probably get rid of this red rectangle, so I don't need to see where that is anymore. Okay, and so I can see that it brought it closer, but I think what I'm going to do now is with my legend box spacing, if I do like -20, then we should see more overlap between those 3 strip or ribbon titles on the top and my legends. Yeah, like that, right? Cool. So hopefully you can see also that we're like making better use of the space on the right side. And I feel like we're there or close to there, right? And so I'm looking at like their dendrogram and my dendrogram, and I feel like my dendrogram is perhaps too wide and the lines are maybe too thick. But I also am not getting much of a margin around the plot. And so like there's a top and a bottom margin for sure, but I don't really see anything on the left or right. So let's maybe make this up to like, let's make it 10 just to see what it looks like. And you know what? I think I know what I did. That I'm applying this plot margin to everything, which is not, well, I think this might be overwriting the plot annotation theme, because I'm not gaining anything on the left and right. Yeah. So yeah, because also in here I made the right and the left 0. So I think what I want to do is cut that out, and then I wonder if I could, can I insert this here with like a theme on that? It would be nice if there was a way, oh, can't merge the title theme element. I wonder what that means. So if I comment this out, it's still unhappy. Okay, it's saying can't merge the title theme element, which makes me think that Let me put back what I had, because clearly cutting and pasting did something wrong. I'm not sure what I did wrong. Let me put this back. So that's there. This works, no errors. Okay. I think what I'll do is I'll grab this, and then after each of these, I'm going to do a theme with plot margin. Okay. And I'll do a plus, and yeah, I'll do that for each of these individually. And we should be good. And that way then, yeah, let's see, that works, no errors. I don't know if it works, just no errors. That's always step one, is no errors. Yeah, so these margins, as you point out, James, are the tricky bits, right? It says legend height width can also be done within guide color bar. Yeah. Okay, that then gets us some spacing around the plot. Good. And now this is probably too high. So let's put this back to 2. And that should be good. And so then what I'd like to do is look at the dendrogram, make the lines a little bit thinner, and probably make this right side a little bit more narrow, right? Like, I think if I look at mine and theirs, let me get to be kind of the same width here. You know, they also have a bit of a larger margin. So I can maybe shrink that down so that plot layout, the widths, let's do like 0.1 and 0.9. And then, yeah, I think that's pretty close to like the same. Yeah, close enough. And then back up in geom segment, when we made the tree, we could set our line width. Let's try 0.2 and rerun the patchwork. Looking to make those lines a bit thin. Again, when we have like, you know, these thousands of lines, being thick just makes them really gangly, right? And so, yeah, I think that's pretty good. So again, what I have done compared to theirs, I'm only looking at panel A, right? Is I've consolidated the legends on the right better to give more space. And then and I'm using the right algorithm, and it's making it wider, right? And so what I would like to do is have this be square. And so something I often think about doing and regret later is in like our heat map, I should be able to do like chord equal, right? So that the spacing on the x-axis, like, you know, 1 unit on the x is the same as 1 unit on the vertical. Let's see what that does. I guess I already had a coordinate system I forgot about. Something tells me I'm not going to stick with chord equal because it always makes things look stupid. Oh, bother. So that's not what I want to do. All right. I'm going to go ahead and remove chord equal. And I think what I will do instead is change this ggsave statement, right? So let's just look at what I get from ggsave before we move on. There we go. And so it is too short for its width, right? And so I could maybe take this up to say 5.5. And what I'm looking for is a height for the width that then gives me like a square plotting window, right? And so I think it's still too short. So let's take this up to 6.0. Thank you all for sticking with me here. I'm not going to get to panel B today. That is fine. It, like I said, is a bit of a mess. So I'm going to use my tool here in preview to kind of look at the size. This looks really close, but it's telling me it's about 1799 by 1597. And so it is still too short. So if I make it like 6.5, again, what I'm looking for is like a square heat map window in here, right? And so I think that looks probably better. And so that's like, I don't know, 1798. This isn't going to be super precise, but like 1798 by 1747. So it could probably go up to like 6.75. And this should be pretty bang on for squareness. And so, again, if I kind of look at the dimensions here, yeah, I've got like 1798 by 1804. That's about as good as I'm going to get, right? And so I guess the other thing I see now is that like my legends are really close to each other. And all that stuff I did to kind of like move them further down, I could probably just make them center justified. And so that was right here. I'll leave the function in here in case you all want to see it later. But let's see what this looks like centering it on the right side of the plot. Right, so like that. And maybe we can add a little bit of spacing. Let's take that up to 20 again. And, you know, there's always like a bit of like back and forth trying to get things to look just right. Like that, right? Cool. So again, this is my version of figure 1A on the top, on the bottom here, and this is theirs on the bottom. Again, a couple important differences. First of all, the way they used heatmap was that they inadvertently had heatmap recalculate distances using their distances, right? So they took the relatedness and then ran that through and calculated Euclidean distances between all of the distances, which distances on distances, for me, it seems like a second derivative in calculus, right? Like that's not what we want. We already have the distances that were measured using our genetic measure of distance or relatedness. And so that's what I've got here. Both are using complete linkage clustering. The other thing that I'll point out that I did was that I worked, as you just saw, to make the heat map, the large heat map, square, right? And so again, it removes that sense that there's more rows than there's columns, okay? So other than that, I think it's pretty close. There's subtle differences in the coloring, which I'm not going to worry a whole lot about, but I think you can also perhaps see how the clusters up in mine relate to the clusters in theirs, right? Like this cluster right here, I think maps to this cluster. This is probably this, and then like this is probably like that, right? Again, the difference in algorithm, I don't think changes the story, right? So don't tell people like Pat's undercutting all the work these people are doing. Like I don't think it undercuts their story, but it I don't know, it gives a little bit of pause of like using tools perhaps without understanding fully what they do. This thing with distance matrices is always a bit of a gotcha. I see this in another package that we use called vegan, where you can give functions in vegan a distance matrix, and it looks to see if it is a distance matrix. But if you give it a data frame, then it's going to calculate distances on your data frame, even if your data frame are distances. It has to be a specific as distance or is distance object in R. So anyway, that's what I've got. Thank you very much for watching this far. If you like this, or if you like this type of content, let me know down below in the comments. I realize these are long live stream videos, especially this one had a fair amount of waiting as we rendered things. One thing I would like to take a try at is revisioning figure 2A. I do not like this figure at all. I don't think the heat map adds anything. I don't think this big heat map adds anything. I don't think the dendrogram really adds anything. I think what the dendrogram is useful for is defining the clusters, right? But then the clusters are presented in a way that you can't really see anything with the metadata. And I think another thing that I would like to think about, now I will leave for you as homework, is how would you represent these strips, these ribbons, as columns rather than as rows? Ultimately, I think these work probably far better as columns than as rows. And I'll leave that for you to figure out. But if you like this, and if you want to see me take another swing at this, kind of the way Pat would do it, or some ideas I have, let me know, and maybe we can sneak something in on Friday to do another live stream to kind of reimagine what this figure could have looked like. All right. Well, thanks again for watching today and tuning in. I really hope you've enjoyed this recreation, even if it's a plot that I don't think is what I would want to share or what I would want to put in one of my publications or the style that I want. I have learned a lot doing this, right? Like I had never made a dendrogram in R before working on this visualization. I learned a lot also about patchwork. And that's a tool I think is really helpful for making these more complicated figures. Yes, there are tools out there like heatmap, like the original authors used, but the downside is you don't always know how they work. They don't always work well with other tools. And yeah, it's like another package to learn as well. You know, the only real new thing that I added to this was that ggdendro package, which was extracting the information from an H-class dendrogram, right? So anyway, let me know what you think of this. Thank you for persevering and watching the whole live stream. And I will see you next time for another